Good afternoon, everyone, and welcome to today's webinar in partnership with Stormwater Awareness Week. I am Katie Johns, Editor-in-Chief of Stormwater Solutions, and I will be your moderator for today's presentation titled Nature Ignores Design That Ignores Nature. We're happy to have this presentation be a part of Stormwater Awareness Week, which is an event that provides free stormwater education by the stormwater community for the stormwater community. It is happening right now, and you can find out more about Stormwater Awareness Week, watch any of the workshops that have already occurred, or register for any of the upcoming workshops at stormwaterawareness.org. And now I would like to introduce you to our speaker for today. Tom Mortensen has over 35 years of experience in site design, landscape architecture, and related design and construction professions. He has expertise in site planning, urban spaces, park and public open space design, memorials and public plazas, retail developments, restoration plans, and integrated stormwater management green infrastructure. He has worked on design projects for the U.S. Forest Service, National Park Service, Boy Scouts of America, Native American tribes, and the U.S. Department of Veteran Affairs. Since 2011, he has been teaching a class at the UWM School of Continuing Education in the Water Technology Certification Program on the topic of green infrastructure and using native landscape and site design for more resilient management of rainfall on sites. So with that, Tom, I will hand it over to you.
And I should shorten that. It's a lot of words, but no, thank you, Katie, and thank you all for inviting me to give this presentation. It's, as she said, based on a class that I've been teaching at UWM, and over the years I've customized it for various groups and conferences, and always try to understand who my target audience is going to be for this, so that I can adapt the content to the audience. So obviously, with this being more stormwater focused, I did sort of tweak the end of the presentation with more project examples, because I think that'll be more interesting for this audience. I'm going to go through some really quick slides in the beginning, just kind of setting the stage about our water ethic and why our relationship with water is so important. So I'll just get started here. Several years ago, back when the green movement really became popular in the early 2000s, everyone was using, green design and, the green economy. And I said, what about water? I think we have to really focus on water, because that wasn't really being talked about when you're talking about LEED or green design. It was very energy focused, which is fine and good. But I think water needs to be, part of that conversation. And so that's kind of how I really got interested in this whole topic and started to look at water from a design standpoint and how we can integrate it into our site plans and our site designs in a more effective way. Just some observations here in the beginning. History repeats, even in Mad Magazine. But when you look at these covers back from the 70s going through the early 2000s, the conversation hasn't changed that much. We're still talking about a lot of issues with pollution, water, going green, all of those things, but I think it's kind of funny when you look at this and you start to see, yeah, history does repeat. And when we are having conversations, I think the difference is that they're getting more robust and they're getting more detailed, which is a good thing. This was a clip from Civil Engineering Magazine. That's Civil Engineers Tour a Rain Garden. And this is probably 10 years old now, but I add these captions to it because I think it's kind of funny. The body language here, back when rain gardens and bioswales and green infrastructure was being implemented, there was sort of a hesitancy for engineers to really adopt this as a means to manage stormwater. And so the guy on the left there is saying, good thing that grant funding is paying for this. And the body language of the guy in the middle, he doesn't seem too interested in talking about rain gardens, but I just thought that was kind of funny, when I saw that in the magazine. Also, The Onion, the spoof newspaper, I came across this the other day. Every place on earth has the wrong amount of water. And, to some degree, that's probably true. But I think, again, it just creates more awareness and, about our relationship with water. The word sustainable, we use it a lot, and I think it's a very tribal term. I personally think it's overused and misused. I think it's just become sort of a generic buzzword. Nothing that we do can be what I would consider to be truly sustainable. I think it can be less non-sustainable, and I think it can be more logically efficient and have less impacts. But when people just slap the word sustainable on something and they just say, look, we're being sustainable, I always question that. Are we truly being sustainable, or are we just being less non-sustainable? And I'm not trying to be a wise guy when I say that. I'm just trying to, again, get it into our head that we can't just greenwash or use these words generically, because they really do mean something. And I think they also challenge me as a designer about if is what I'm doing truly sustainable in the design methodology that we're using. So when you talk about stormwater, I mean, these are examples of some projects we did not design, but I took photos of. People went to college to learn how to do this, and agencies approved it, and contractors built this. And I think this is about as far away from our relationship with water, this free resource that falls from the sky. What do we do with it? In these photos, we treat it like a waste product. We don't really have a relationship with it in a very positive way. This is just, get it done as quickly and efficiently and cheaply as possible. Sometimes we see facilities like this, and I call it stormwater jail. We're taking this resource and we're putting it into a cage. And I think that says a lot about how we relate to water and what we do with water when we're designing a site. The photo on the left was supposed to be a stormwater facility, and this is in urban Milwaukee. And I took this picture because I had no idea what they were trying to accomplish here. This is just a mystery to me as to how effective this is going to be on slowing down or treating or infiltrating rainwater in an urban environment. To me, it looks like a water coffin. And then, you see a lot of rain gardens that were well intended when they were installed, but then over time they just become kind of a nuisance to the facilities maintenance people, and they just kind of treat it like like a regular landscape bed or a lawn bed. So I have some other examples, as we get through this. So stormwater management, this is awareness week. I sometimes question, do we really manage it? Can we fully manage it? And not every rainfall is a storm. So when I'm working on designs for green infrastructure, I use the term rainfall integration. It just has a different connotation than stormwater management being very severe and very important. But rainfall integration kind of sets a different mindset when we're designing sites and talking about water. A couple, observations too, like that we use more water in a day than we use oil in a year. And how many gallons? 105,000 gallons of water to make one car. That's pretty eye-opening when you start to think about how much water is being used and for what purposes and how we get it, and is it treated water that we've paid for to make it potable, and then are we using it for other uses that maybe we could think differently about it. And that's when I get into talking about the water ethic, and you're going to hear me talk about that throughout the whole presentation. So I always ask this question in the class that I teach, and I kind of make a joke out of it, but how many bottles of water in volume does it take to make one bottle of water? And so I went on the internet, so that means it's got to be true. But I found a guy who worked in the bottling industry, and he tried to do a calculation on it, and he came up with 88. When you talk about the labels and the caps and the packaging and everything that it takes to generate one bottle of water, takes 88 bottles of water in volume. Now, even if it's half that, even if it's 40, that's still a lot of water to make bottled water. And I'm not against bottled water. I think it has a place, but I think we use a lot of it. And when you connect that dot to 88 or 40 bottles of water in volume, you start to have a different thought, process about that. So I was down in Florida, and they receive about 54 inches of rainfall per year, but yet they're required to use recycled water for their landscape irrigation, which I think is really interesting. That that is a mandated protocol down in Florida where they get a lot of rain. Up here in Wisconsin, where I'm at, we get about 37 inches of rainfall per year, and we don't have to use recycled water. So I think that's an interesting paradigm, and you start to see other parts of the U.S. where they're starting to do some, again, logically efficient things. They're not sustainable; they're just logically efficient. And one of them was at the Seattle airport. I saw this sign in one of the restrooms. So they're using rainwater from the rooftop of this large building, terminal airport, and they're using that for flushing their toilets and urinals, which I think is a very logically efficient approach and something that we're going to see more and more of in our designs and in our thought process around water. PFAS are a big thing now here in Wisconsin, but also everywhere. These are forever chemicals that have gotten into our water system, and they're now finding traces of PFAS in white-tailed deer and bald eagles. So again, it's kind of an alarming thing when you think about what's happening to our water. That the DNR, has named 240 waters in Wisconsin as impaired, and that's unsafe. That's not good water. And they just added 51 more to the list. And you start to think about how we're pumping groundwater for not just municipal use, but for large scale industrial farming use. And it's going to have a cumulative effect. We're going to start pulling water out of the ground. In fact, we already are before it recharges. So we're taking more than what's being replenished. And that's going to have a cumulative effect, over time. And like I mentioned, large industrial farms called CAFOs. Wisconsin now has over 300 of them. So again, and it impacts our water, not just from pumping, but from the pollution that is created by these large scale industrial farms. So we're starting to see it in our lakes and our inland lakes and our Great Lakes. This is toxic algae. Lake Erie is very shallow. And a lot of the states that are around Lake Erie are now suing the EPA because they're not enforcing regulations or doing anything about pollution from agriculture, large-scale industrial agriculture. And this is the result of what's happening in those waters. So again, these are our inland lakes here. I took this picture in 2016 on the right. By August, you cannot swim in some of these inland lakes because they're just choked with toxic green algae. So are we doing better? Are we really getting better? And I always go back to this slide, some not so recent news, the Clean Water Act of 1972. How is that working out for us? And I would argue that probably not too well. It's done some great things. However, it kind of sidestepped the whole connection between surface water and groundwater. So groundwater isn't controlled or isn't part of the Clean Water Act. It's all just surface water, and we all know that they're interconnected. So I don't think it's really an effective catch-all. We like to say, oh, we have the Clean Water Act, that's fine, but I don't think the politics around it are working very well. So um, now I'll move into more of the green infrastructure and why is it important? And there's a lot of reasons why it is important. We know that if you work for a design company or an engineering firm, we know why we manage stormwater. However, when you start to think about how much is getting pumped every day, our groundwater, and that's not getting recharged, like I said before, I think one big thing we have here in Milwaukee and other areas in the Midwest is the combined sewer. And when we get a large rain event, those sewers overflow and it goes right out into our drinking water. So I think every gallon that we can capture and not put into that system is going to have, a positive effect on the outcome of what happens after a rain event. And there is some water privatization happening. There are some water hunters that are looking at the Great Lakes as for private use. That's a little scary. Now we do have the Great Lakes Compact, but there's still always going to be a demand and a pressure to privatize water because it's becoming a big and bigger issue throughout the U.S. Um, so I'll get into, that we all know kind of the water table, what used to happen here. We get rainfall, it would get into the topsoil was plentiful, it would get absorbed into the ground, and wetlands and some other water bodies were actually fed from below. It wasn't sheet flow, it was actually, fed from below. And what's really interesting when you think about hydrology and landscape is how different types of vegetation have adapted to certain types of hydrology. And I'll give you an example. I have a friend who has 160 acres up in Anago in northern Wisconsin, and it's really, really a flat piece of property. There's probably maybe 4 or 5 feet of relief across 160 acres. But when you're in the lowland areas, you see tag alder and basswood and more bottomland species. And as soon as you rise up by 2 to 3 feet, it goes into hardwoods and oaks and maples. And I find that really fascinating that how this vegetation has adapted to the hydrology of where it is. Soil has a lot to do with it. But in this case, it was all based on hydrology. And I think it's really interesting when you can observe that in nature. And then you always have to ask yourself why. why did that happen? And it happened because these plants are adapted to grow where they're supposed to grow. So when we're doing site design, when we're doing landscape or vegetation plans or that type of thing, I always have to keep this in mind. And I'll share an example of that with you in one of the case studies. So impacted and manipulated patterns of hydrology, we come along, we strip off all the topsoil, we regrade the site, with heavy equipment, and then we come back with a paintbrush and we put a little topsoil on the top of it. And then we wonder, why isn't it not absorbing into the ground? Why are we sheet flowing everything? And that has an impact as well. So in areas where you don't have to disturb the site, if it's a large site and you can actually preserve some of that sponge, is what I call it, we always look for opportunities to do that rather than mass grading the whole site if you don't have to. Not only does it save time and money, but it also helps with the hydrology of the landscape. So we've always been trying to take water and make it go away, and there is no way. Water is not compressible. It goes somewhere. There's always a downstream effect. And I think we have to keep that in mind as well. Like you might get it off your site via a pipe, but that then has to go somewhere. So again, having that connection and not just making it go away because it won't is kind of changes your thinking about water. So here in the Milwaukee area, all of the streams and tributaries in the 50s and 60s were channelized with concrete. And that was well intentioned. There was a lot of, we're going to be more efficient. We're going to prevent flooding on adjacent lands. We're going to create more developable land. But it had unintended consequences downstream because the velocity of water that moved through these systems was uncontrollable by the time it picked up more and more velocity as it went down closer to the river. So now what they're doing, it's a project called stream management. They're removing all of these concrete channels because they understand, oops, that didn't work for us. And they're removing it and they're trying to create more of a natural river corridor throughout the urban environment, which I think is great. I mean, we're limited on space in some of these areas because of adjacent development, but they call it stream management. I call it mismanaged stream unmanagement. We mismanaged these streams for years, and now we're trying to unmanage them because again, nature always wins. So again, that just kind of changes the mindset of we're trying to control nature. That didn't work. Now we're trying to let nature go back into control. So some contemporary and integrated patterns of hydrology and landscape. There's a lot of different ways that you can achieve this on a site. We use, a lot of dry stream beds, which you see on the right-hand side there. Not only are they aesthetic feature, but they slow down rainfall. They slow down water and they let it absorb if the soils are appropriate for infiltration. The bottom right photo, that's a water quality swale. So it's a very, very low depression, but a lot of water moves through that very, very slowly. And in the soils on this particular project out in Oconomowoc are very sandy, and gravelly. So that water actually infiltrates. It doesn't go into a pipe, it doesn't go into a pond, and it doesn't go into a storm sewer. It all gets infiltrated on site. And then of course there's, other ways that we can capture water, roof water, and use it for other purposes. Um, I think the thing about contemporary uses of these systems and green infrastructure is that has to be in the right spot. It has to be on the right site. Not every site is going to have every option to exercise these protocols. So like the photo up on the upper right, what you see there is you see a pretty robust planting scheme there, but it takes real estate. It takes space. You need the space in order to make these systems work. And I'm a big fan of permeable pavers, especially up here in the upper Midwest where we get a lot of winter, freeze thaw, that type of thing. There have been a lot of projects up here where they've tried to use permeable concrete and permeable asphalt. And over a couple of years, just because of winter and freeze and thaw, it turns into popcorn. It just spalds and it clogs up. And it just doesn't work very well here. And when you use permeable asphalt and concrete, what do you do when it cracks? Whereas the pavers are pre-cracked. So I'm going to give an example of a project that we actually did here in the north part of downtown. We designed a system that was going to be used for permeable pavers, the photo on the bottom right. However, between the contractor and the owner and some other circumstances, they decided to go to permeable concrete. And I did warn them against it. I said, in this climate, I've just never seen it perform well over years. It just kind of crumbles apart. Well, we're going to do it, and this will work for us, and maybe in warmer climates it would work, but up here where we have freeze thaw, it is not a good solution. So 2 years later, they ripped it all out and they put in permeable pavers. And we already had all the under drains in place and all the stone layers below this. So it wasn't as if they had to rip all of the stone base out and the sub base. They were able to just use what we already had in place. And I just went past this site a couple weeks ago, and it still looks just as well as the day that we put it in, and it's performing really, really well. So again, in this area, I'm a big fan of permeable pavers. Blue roofs is another thing. We've all heard about green roofs and how beneficial those are to absorb rainwater on rooftops and act as a sponge, which they are. But there's also blue roofs, and we've been involved in a couple projects where, we've been able to implement blue roofs where you can store water on top of a roof if it's, the building is structurally sound. You can hold it back from going into the storm sewer. And then after the first storm event or the first flush, you can slowly release that water into the storm sewer system, or as in the case of the Seattle airport, use it for other uses. So again, it's changing our thinking about this resource and what we can do with it. There's some newly integrated systems that are also very popular. The city of St. Paul, Minnesota has adopted using these systems in all of their urban trees and streetscapes. It's really a way to support pavement, so a plaza or a public walkway, but you support it on these grids that you can see in the upper left there, and then you fill that with organic soil amendments. You plant your trees, and they do so much better than if you try to plant them, in a concrete vault surrounded by gravel. The other benefit too is that you can direct stormwater from the street or the paving into this series of pipes here, which not only water the trees but slow it down. And then eventually your last line of defense is getting into the storm sewer. So this is a really integrated system, and it takes a lot of thought and design and detail to make these work. But and there have been some examples here in Wisconsin too, in front of Camp Randall Stadium. It's amazing when you see how these trees perform after just a few years of being planted in these systems compared to the old method where you cut a hole in the sidewalk. It's 5 by 5 by 5 pot or a cube, and then you jam a tree in there and torture it to death over the next 15 years. Those systems never seem to work very well long term. So again, we're seeing more and more of those opportunities. Now I'm going to get into more of like my design approach and techniques. If, up here again in Wisconsin, the landscape is very simple and bold. And, it's diverse, but it's not complicated and vague visually. It's very simple and bold. And so if we use that as a design technique and we think about that, I think it has a much more stronger visual impact, but also an easier way to maintain a landscape. And I'll get into an example of that in one of the case studies. I always challenge the knee-jerk approach. If you have a client and a project where everyone is sort of on board with implementing, green infrastructure or native landscape, exercise that. Don't just go to the cheapest, quickest way to do it. And the example on the bottom right there, that's actually a Cabela's store in Wisconsin, and that's a stormwater pond. So very, very different looking than those first examples I showed you in the beginning of the presentation with rocks surrounding them and rectangles. This is more of something that might occur in nature. And we did implement a strategy here where we used both seed, plugs, and woody shrubs to landscape this pond to make it look like something that actually might occur in nature. And again, simple and bold in the urban environment, just having a swath of switchgrass or some other type of a robust, salt tolerant, urban tolerant plant, less is more, right? Simple and bold. This is very easy to maintain compared to if this were planted up with, little gumball shrubs and lollipop trees and hamburger patty evergreens and that needed to be sheared all the time and mulched all the time. This is just a very, very simple way to buffer a parking lot in a simple way using, simple plants. I know this is difficult to read, but I just wanted to talk about Chippewa Nature Center in Midland, Michigan. We did this project years ago, and the design team, we were all collaborating with the owner, and the owner just happened to be a bunch of native plant ecologists because they work at a nature center. So it was really a good group of people to work with. But we were talking about water, and people were really struggling with, like, Tom, what are you talking about? What do you mean by this? Like, I hear these words and I know what you're saying, but I'm not getting it, the full picture. So I spent a little time and I did a little sketch, in between meetings. And this just shows what happens when the water comes off the roof and what we can do with it. We can turn it into an educational opportunity. We can slow it down. We can create a water feature out of it with a series of waterfalls and weirs and drops. And then, our last line of defense is that maybe it goes into a large bioswale, and then people walk through this system, so there's a connection to it. And that's kind of what we ended up doing in the front entry, is we took this water, we put it in the cistern, we released it slowly, and then now people walk through this landscape when they go to the nature center. And again, it's just a connection to stormwater, it's a connection to rainfall, and it's a visual and aesthetic, connection. And then again, off to the right, then we created a bioswale in the parking lot. When we first started this project, the parking lot was like a typical retail parking lot that you would see, at a Walmart. They didn't have this wide of an island, so we widened the island to about 40 feet. We created bioswales through here with native vegetation, groves of native trees, and we put a boardwalk through the center of it. So now when kids come to this nature center, they get dropped off on the bottom right there at the bus drop, and then they walk through this landscape before they go into the nature center. So I think it sets a vibe for people, coming to this. And it was really just through a series of discussions and ideas and having a client that was very open-minded that, that this was able to work. And it turned out great. I haven't been there in a couple of years, but it really came together well. River Edge Nature Center. So the story behind this is they were building these series of classrooms on the left here. So this is just obviously a rendering of the architecture and the landscape. And the architect said, well, we're going to put a green roof on here. And then I raised my hand and said, why would we put a green roof on a one-story building in the middle of thousands of acres of nature preserve? And he sort of looked at me, and I wasn't trying to, again, be a wise guy, but I said, think about it. It's a one-story building, and all these are classrooms for children, and they're not going to see it. They're never going to see this unless you put a ladder up there or some kind of stairwell up there. But that wasn't part of the design. It was just going to be a green roof for the sake of being a green roof. And so I challenged that. I said, what if we do this instead? Instead of a green roof, what if we create a rain curtain where stormwater now falls off of the roof and comes into a dry stream bed, and it splashes, and kids can go out and they can smell it and they can hear it and they can see it and they can touch it, and they can just interact with this rainwater. Now that's a teaching opportunity. And so we ended up using that methodology on this project, and all of that water then goes down to some community garden beds that's used for irrigation. So again, we're connecting this rainfall with an actual purpose rather than just trying to make it go away. This is a photo I share with in the class that I teach, and I just want you to kind of think about this as I'm explaining it. So this is the Mecan River in central Wisconsin. What you see here is what happens in nature. You have a low flow channel, the river. You have floodplain, these alluvial areas where during large storm events or rain events, the water has somewhere to go, and so that's the floodplain. And then the side slopes are all hardwoods. And when you think about that, it's interesting because there are no trees down in the floodplain. There are no trees down in the low flow channel. The hardwoods, and again, are adapted to grow on the side slopes. So, me, so when you try to force green infrastructure or that methodology into the middle of a parking lot, like in the upper right, that's opposite of what happens in nature. First of all, that the island is way too narrow to be effective. And then all those trees were planted in the bottom. I went back a year later, they were all dead because they were loaded with sediment, salt, and probably just way too much water. Trees are on the side slope, and then you have the low flow channel and you have the floodplain. And so again, this is just against what actually happens in nature, and trying to force green infrastructure into parking lot islands just never works. It's not enough real estate, like that slide I talked about before. If you want these to be effective, you need space, you need room, and trying to force it into an island, it's just not going to work long term. And the photo on the left, I mean, I guess it was well intentioned, but they planted native species like there's butterfly weed in there and some other native species, but they planted it in the middle of a quarry. And that stuff just fried the first year. Again, this was designed, this was permitted, this was built, and then it failed because again, that is not what happens in nature, and it's actually the opposite of what happens. So there's three types of configurations and methods, I guess, or processes that we use when we're thinking about these bioswales or bioinfiltration basins. There's full infiltration depending on the soil. There's partial infiltration, and then there's flow through. So in really tight soils, you're not going to be able to infiltrate water, but you can pass it through a system of vegetation. And it's going to do a couple things. It's going to slow it down, and it's going to help trap sediment, and it's going to make the outcome on the far end of whatever that system is better than it was when it came off a parking lot and went into it. The other thing that I've learned over the years is that there's different types of geometry of the basin, the planter, the swale, but avoid single inflow. If you had one gigantic pipe just throwing water into a detention basin or a dry basin or a bioretention basin, you're going to get erosion and you're going to get scouring. But if you can dissolve that and space it out, now you have water coming into the system a lot slower at various points, so you don't have as much scouring and erosion, and it's going to slow it down and it's going to infiltrate. And I'll get to an example of this project later in the presentation. So those are kind of some of the systems and things that we use when we're doing that. I also think water can be art. If being a landscape architect, I think there's opportunities where you can, when it does rain, water becomes art. When it's not raining and the system is dry, it can still be very functional and aesthetically pleasing. You just have to be a little bit creative about it. And in Europe, I think they're, pretty ahead of the game, in parts of Europe where they have these things called water plazas. So when it rains, it's a water feature. And when it's not raining, it's a public plaza. So it's multi-use and people interact with it. And again, it just creates this connection and this awareness to water instead of calling it, a waste product. It's an actual resource. So some of the challenges and roadblocks that I've encountered over the years, in doing this type of work is, there's this perception that sites always have to look good and they can't be expensive. We got to do it low cost. And I always hear this, I want low maintenance. And, it just makes my toes curl when I hear that because I always say, well, there's maintenance and then there's higher maintenance, but low maintenance or no maintenance is just not an, it's just not even achievable. And so having those real conversations with people up front, I think is really, really important to set the expectations. Even if they don't want to integrate native landscape, but they want to have some sort of a bio basin, there's going to be maintenance. But is it less expensive than a lot of pipe and a big pond that's eating up a lot of real estate? Yes, it doesn't have to be expensive, but it doesn't mean it's going to be cheap and easy. Here's an example of a project that we worked on. The company was based out of Montreal, and they had a sustainability, there you go with that word, but they had a sustainability initiative where they didn't want to, in the new facility that they were building, they didn't want to mow, acres and acres and acres of turf. And then they said, Tom, is there, something else we can do? And I said, of course, we can implement, native landscape, but there's an upfront cost, but that goes way, way down in maintenance as time goes on. So the column on the left there is if they would have just used turf, and I got these numbers from several landscape maintenance contractors, and then I averaged them. So when you start to look at the math of what you spend every year on a site this size for maintenance, just of turf, and that includes spraying weeds and all the other stuff that you need to do to maintain turf, irrigation, that adds up pretty quick. Whereas if you implement native landscape, yes, there's a bigger upfront cost, but you'll see how that maintenance then goes down over years because it becomes a self-sustaining system. And so the numbers at the bottom were kind of an eye opener for everyone involved in this project. And obviously they went with the native landscape as their option. some of the other challenges and roadblocks, when we talk about this is that sometimes, the client doesn't have an aesthetic tolerance for native landscape, but it doesn't always have to look like a wild hair day. It doesn't always have to look like a crayon box blew up. And I have some examples of that later on as well. It's really hard to find general contractors who understand what it takes to implement these strategies for stormwater and for green infrastructure integrated with native landscape. They just don't have a lot of knowledge about it, and there's not a lot of landscape contractors, at least in this area, that have a lot of knowledge about it as well. So if you don't have the right team put together, no amount of written specifications are going to guarantee success. It really takes a lot more than lines and words on a piece of paper to make this stuff effective. Some of the other challenges too are, the municipal codes and mandated protocols. They're so outdated and they don't incentivize using green infrastructure or native landscape to manage stormwater. It doesn't exist in their code. They just have a typical stormwater management approach, which is probably outdated and just based on pipes and ponds rather than native landscape. Um, and then there's also that, that aesthetic tolerance. Again, the general public, sometimes they don't like it the way it looks, but I've proven them wrong because I have an example where it actually turned out really, really nice because I kept it bold and simple, not complicated and vague. Sometimes I'm handed a site plan. They're like, okay, Tom, we're done. Now you can decorate the damage. And it's because they brought me in way, way too late. If they would have brought me in earlier, we could have solved a lot of these issues. And, this is the result of just, again, those slides in the beginning, just trying to get it done. And no amount of landscape can really, solve all the sins of bad design. So the key to success in all of this, and this is probably very obvious to many of you, but it's really getting involved early with a multidiscipline team. I'm a landscape architect, but I'm also a site planner. And, having a hydrologist or, an ecologist, especially, I mean, I'm a landscape architect. I'm not an ecologist. I'm not an arborist. I'm not all of those things having to do with plants and vegetation. I'm not a horticulturist. I'm a landscape architect. I design land and landscape and plantings are a part of that. But getting everyone to the table early can save so much time and so much money and so much frustration later. And that's really the key to success in implementing these systems. So all right, now I'm going to kind of jump into for the next 15 minutes or so some project examples. Sauk Prairie Memorial Hospital up in the central, just kind of south central part of the state. Um, this was 340-acre parcels. They were going to build a new hospital here. It was all ag field. It was big sky, very wide open site. Um, Beautiful views to the bluffs off to the east along the Wisconsin River. And we had offsite flow from a large agricultural field across the street, and we had a state highway on the left. So this water pattern, this drainage pattern, we respected that. I mean, if we were to try to fight that and change it, it would have caused a lot of regrading and a lot of erosion. So we said, okay, let's just see what happens if we leave that intact and work around it. And then the four rectangles that you see that down in the corner there, we were across the street from an airport, and the FAA flight path was right where those four rectangles were. So we're like, okay, well, what can we do there? There's a lot of things you can't do in the flight path of an airport, such as light poles, trees, cars, buildings, permanent structures. So what do we do with this space? How can we turn this into a positive? And there were also a lot of other site challenges. So the yellow is the flight path, but we had this offsite drainage, we had residential development, we had a jurisdictional boundary, or like trisecting, the site as well. We also had a state highway on the left that we had to get access to. So it was a really, really challenging and complex project to try to get it done. And at the end of the day, this is what we ended up with. And I think one of the reasons that it was so successful is because the owner or the president of the hospital, his stakeholders, the facilities management people were all at the table early on when we were developing this plan. And when you go to a hospital, typically you're pretty stressed out. You are, or the people that you're with are pretty stressed out. So we wanted to make this very intuitive, very safe, very simple, but also aesthetically calming. And so they said, we don't want to mow turf. if this would have all been mowed turf, they would have had such a Canadian goose infestation problem. They would have never been able to keep up with it. So we implemented a short stature meadow mix for all of the seeded areas. And then again, those biobasins. So I have some examples here of how that turned out. The other thing we had, which was great, was sand. There's certain parts of this state where the water infiltrates really, really well. Sand, gravel, alluvial, glacial till. And then there's also parts just here, even around Metro Milwaukee, that are just hard pan blue clay. So you can't apply the same infiltration or technical standard to green infrastructure in those two types of soils. There's just one is going to work well, one is probably not going to work at all. So how do you develop a strategy around that? Well, here at the hospital we had all sand. So instead of exporting it and then importing organic soil mix, we actually mixed soil on site with the sand so that we were able to, meet the DNR technical standard for infiltration soil just by using the resource that was already on site. And so this is what we ended up with is a series of those basins in the flight of the airport. Again, more of a natural shape to them. They're not all just rectangles like I showed on the example, but we planted the side slopes with some native woody vegetation. This was planted with plugs, and I'll tell you the reason why this was so successful is because in our specifications, we tied the landscape contractor who was to install this landscape to a 3-year maintenance program that had to be implemented by a firm that had proven experience to take care of native landscape because the landscape contractor did not have that on staff or in-house. So they had to bring in a specialty firm to take care of this native vegetation and these bioswales. And so the photo on the right is after the second season. I think that's pretty remarkable. They managed any woody invasives. They managed anything that was going to come in here that was going to take over and be a non-native invasive problem. And because they tied that contract to the operation and maintenance budget for the hospital, they were able to get this thing established. And to this day, I believe that same company is still managing this native landscape. They've adopted it and they know it better than anyone else. So you can't just like put it out to bid every year and expect that another expert's going to be able to come in and do it. That's how you get finger pointing. So by tying that responsibility together, we avoided finger pointing. And again, in the parking lot, we have some native landscape that's just very, very simple and bold. Lily Heights Park, bioinfiltration basins. This was a project where grant funding was granted by Milwaukee Metropolitan Sewerage District. It's a mouthful, MMSD. So they issued a grant for the planting of this bioswale. Again, you can see on the left, the island is wide. It's not a 9-foot sliver. It's a 35-foot wide island that we were able to implement this bioinfiltration basin, and it turned out great. The next year, and everything just took off. And the parks director and the city forester, they adopted this. They took care of it. They weeded it. They got it established. It turned out great. And then the next year, it failed. Well, why did it fail? Well, I'm still learning every day when I'm doing these projects. I don't have all the answers, but the reason that this one failed is because we put too fine of a filter on it. We had the perforated drain tile pipe wrapped in a sock in a trench filled with pea gravel with another layer of fabric around that. It was too fine of a filter and it clogged immediately and then it inundated. So I got a phone call from the parks director. He said, Tom, we got a problem. Like this water is not going down and it's been a couple weeks. Can you come out and take a look at it? And I was like, yeah, this is a learning session here. What can we do? So we took out the pipe, we took out the pea gravel, we took out the fabric, we backfilled the trench with a larger aggregate that had more void spaces in it so water would move through it a lot quicker. We removed the sock off of the drain tile and the water went down immediately. The interesting thing about this, though, is that none of the native plants that were planted died. They just went dormant and they popped right back after the soils dried out. Again, very resilient plants, but it all came back. And that was great because, it was a $88,000 grant. That would have been an expensive, project to have to replenish, and the native plants just came right back. This is a very big project that I was involved in down in the village of Greendale, outside of Milwaukee. This treats 50.94 acres. And these are bioinfiltration basins along Grange Avenue. So there was this huge wide median, and they're like, can we get a grant and can we use this for treating stormwater? And just some basic facts about it. It's the 6 foot depth. How many acres does it treat? How did we connect the under drains to the storm sewer? But the big thing here is it removes 770 pounds of TSS annually. So it's a very robust system. And again, it works because we had the real estate to actually get it to work. And again, this was a grant funded through MMSD, so they received funding, to take care of it. And just some photos of the installation, you can see how big of a system this was, and how robust it was, and the aggregates that were used, and the size of the pipe. And then, the photo on the right there is the organic soil amendments that the plant's growing, but also is based on a technical standard for infiltration. So kind of a complex puzzle to put together to try to recreate nature. And it turned out okay. I mean, we didn't do the design of this. This was done by a different firm. And it turned out okay. I mean, there was, we have some Joe Pye weed and some other native species in here. But what happened is over the years, it got out of hand for them. They didn't have, horticulturists on staff. They didn't have ecologists on staff. They had high school and college students on staff over the summer to try to, maintain this. And they weren't aware of what to do, and it got away from them. And it turned into a big patch of Canadian thistle and Queen Anne's lace and other, invasive species that just take over these types of systems. And it's because those plants were allowed to go to seed. So it got away on them. And what they did is they started mowing it like turf. And they said, well, we can't do this. We have this grant, Tom. How can we do this, redo this, but make it easier to maintain? And I went back to this is what happens in nature. It's simple and bold. It's a lot easier to maintain. So now if you have a college student or a school student walking through these beds, and they're amongst a huge swath of purple coneflower or butterfly weed, and there's one rogue plant coming up in the middle of that, that that's not supposed to be there. So we really simplified the maintenance of these systems. And so this was the result of the replant. You have just big, bold groupings of native plants that to me are a lot easier to maintain than what we saw before, which was what I referred to as a crayon box blowing up. And there's one of everything, and that just doesn't happen in nature. At least, in my opinion, I think this is just a lot easier to take care of for the village. So it was, a situation that got out of control, and it's a success story. We were able to come up with some unit costs for this as well. Now these are many, many years old, so I'm sure it's more than this now, but we used a multiplier of $3.53 based on one of the basins that we designed, and then we applied it to the other three areas. So there are four basins altogether, and able to come up with some cost estimates so that when they were purchasing the plants and installing it, they had an idea of what that budget was going to cost. Now that doesn't include maintenance, but this was just the redo and the reinstallation. Trinity Woods is a college campus in Milwaukee, up on the west side of Milwaukee in Wauwatosa, and we were able to secure a $1.3 million grant from MMSD to implement GI on this site. And the reason that was so robust is because this part of the city did not have a lot of examples of existing projects that had GI. It was being implemented in very urban environments and other areas of the city, but in this area, it was very, it was one of those like poster child for green infrastructure. And so, we use these big swaths of native vegetation in the bioswales, but we also use permeable pavers throughout the parking areas. Now, I will say one thing about this photo is when you use permeable pavers in the parking spaces, but you have regular asphalt or concrete for the drive aisles, what can happen is you can get a lot of sediment load on the front edge of these permeable systems because it sheet flows off of solid pavement onto the permeable pavement, and that's taking a lot of sediment, and it can kind of load up the pavers a little bit. So there's a little bit of a, an awareness that needs to be created there when you're talking about these systems. But again, this was $1.3 million in grant funding to get that project done. Olympia Fields and Paps Farms, that's west of Milwaukee and in Oconomowoc, and there's a common theme here being Milwaukee and the beer capital. Um, but it's an interesting area. We've been working on that project or that whole development for probably the last 20 years. It was actually started when I first started here 20 years ago. And our civil engineer, who's been the senior manager on that, has pretty much worked on all these projects out there. Again, this is glacial till. This is alluvial soils. This infiltrates really, really well. So we were able to, create these infiltration basins, but they didn't have to, all again be a seeded mix. They could have this sort of bold tapestry like you see in the photo here, which, as people are walking or they're visiting the site or they're in the hotel or whatever, retail establishment, this doesn't look like one of those ponds in the beginning. This looks like an actual natural feature. And, we did that intentionally. This was very intentional to weave these patterns, through the landscape and create this as more of an aesthetic feature, rather than, a liability that no one wants to take care of. So it was really a fun project to be involved in, and it's ongoing. And no amount of stormwater in Paps Farms leaves the site. It doesn't go away. As I said before, it all stays on site and it all gets infiltrated. So that's been a really fun design challenge where civil engineer meets landscape architect meets developer, and how do we get this all to sync up and work together? And rather than using landscape as an afterthought, I'm brought in very early on these projects to really, um, try to implement a strategy with the civil engineer and the municipality on, how we can treat the stormwater in a more effective and aesthetic and natural way, other than, just ponds and pipes. So moving forward, these things are incremental, incremental in change, region by region, city by city. I think, NGOs and municipalities really have led the way, but I'm seeing more and more private development implementing these strategies, which is a good thing compared to even like 15 years ago, 10 years ago. We're seeing more and more incentives through grant funding for private development to implement green infrastructure and stormwater features in a more robust but natural way. There's some good publications and books out there if you want to get your hands on them. Again, this will be recorded, and if you have questions, you can always reach out to me. But these are some really, I think, really well done books. There's probably been more done since I've gotten these, but just kind of makes you think a little bit differently about your design and what it looks like and where it exists on the site and how big it needs to be and what it's vegetated with and what people are going to see, at the end of the project. There's also some, talking more about our water ethic and our water quality. There's a lot of books out there. The one on the left, I think, is really, really a good book. It's not doom and gloom, but it really opened my eyes to a lot of things that are happening, not just in the upper Midwest, but nationally with our relationship with water and our water ethic. And so it was just a really good read. It wasn't a long book, but I learned a lot from it. And it really kind of gave me a different mindset about our water ethic and our relationship with water. There's also some, documentary films out there about water. Again, if you're bored on a weekend and it's raining and you want to check some of them out, they're pretty interesting. And then, back to what industrial agribusiness is doing to our water quality. There's some pretty shocking documentaries out there about our water quality. And the one in the middle there, Sold Down the River, is filmed up in Kewaunee County, Wisconsin, which is up by Door County by Green Bay. 38% of the people in that county cannot drink their water. You'd think that would make national news. And it's contaminated with E. coli, it's contaminated with nitrates, and it's because there's such a huge concentration of industrial dairies up in that part of the state that they have a real problem. And so again, if you're interested in that topic or you want to become more aware of what's happening with our water, not just in Wisconsin, but this is happening in Iowa and everywhere, these mega dairies or these mega farms are not good for our water. And we're seeing more and more day by day how it's impacting it. And then there's also podcasts that I learn a lot from. There's this one here, Talking Underwater. You can learn a lot from just hearing people, product people or people who are in the municipal realm, and having to deal with MS4 permits and other disciplines, whether it's civil engineer or a hydrologist or a geologist. There's some great podcasts out there, and it's kind of geeky, but I really enjoy them and I learn a lot from them as well. So it's not something I spend all my day doing, but if I'm on a long walk, sometimes a good podcast, you can learn a lot from that. So I think we have some time for a couple questions, but again, if you'd like, you can email me, then, or the webinar can email me and I can answer those questions. So, all right. Well, thanks again.
Thank you so much, Tom. That was great. And yeah, we have time for maybe one or two questions. And again, any we don't get to today, we will do our best to answer offline. So, all right, let's see. Tom, is there a reason outside of cost that people may opt to use detention ponds and settling basins instead of bioretention?
It's quick, it's efficient. Ponds are very efficient at settling out sediment. It does eat up real estate. So, when you think about the cost of real estate and dedicating that to a pond, that does have a cost to it. But I think, over the years, it's just been sort of the standard, put it in a pond, meet the minimum requirement. We don't have staff to maintain anything else, so that's going to be our best choice there. And I understand that. Not
Mhm.
everyone is going to be able to implement GI or maintain it or dedicate staff to it. So yeah, I think, even though, digging a pond, depending on the size and how much real estate that's eating up, it can be costly as well. Pipe is costly, to get the water to the pond, but it is really sort of the first, approach to stormwater was always, let's do the pond, and that's kind of changing a little bit.
All right. How do you handle sites that have karst or are in areas of enhanced risk of sinkholes?
That's a good question because we do have many areas in Wisconsin that have karst geology. So that's shallow topsoil and shallow bedrock. And there's a lot of fissures, and that's almost like a direct bat phone or direct line right down into our groundwater. Um, I think the best way to understand that is to hire a geotechnical engineer if the product or the project warrants it, so that you know what you're dealing with. We advocate and we try to convince our clients that having a good geotechnical report, and sometimes it's required. If you have to prove to the agency or the state or the DNR or whomever that you're going to get infiltration, you need to have a geotechnical report, and you need to be able to prove to them that the soil is going to be capable of doing so. And so, yeah, in karst geology, you can encounter a lot of variables. And I just think everyone mitigates risk and sleeps better at night when you have a good geotechnical report.
Absolutely. Well, unfortunately, that is all the time we have for questions today. As I've said, we'll do our best to answer the rest offline. So, Tom, thank you so much for sharing your insight and expertise with us. It was really great. I know people have been asking. Yes, there are attendance certificates for this. So after the webinar concludes, you can stay online and you'll be presented with a survey in your web browser. You can also access the survey by clicking the link in the follow-up email that will be delivered to you. You can just complete the survey and then you will receive an email notification when your certificate is ready. And that is all the time we have for today. So thank you, Tom. And on behalf of Stormwater Solutions and Stormwater Awareness Week, thank you so much for joining us.
All right, thank you. I enjoyed it. Thanks.